I'm wrong because it was the holidays, I forget things. Anyway, what else do we have in chapter 16? We have the capacitance of a capacitor is given by, so this delta X can be written as D, sometimes he writes it as D. Douglas Cotton. Okay, so the capacitance of the capacitor can be written as epsilon naught A over D. A is the area of the plate. The capacitance of the capacitor can be written as epsilon naught A over D. Epsilon naught is a number. Okay, it's and you're not required to remember it because you're given all the constants for your APs. The number is 8.85 times 10 to the minus 12. All right, so you can have capacitors in parallel or series. Capacitors in parallel.
Yeah.
And then you have series. When they're in parallel, this is the battery. They look like this. This is the capacitor. Alternate routes that they can take. If this is C1 and this is C2 and you have an equivalent capacitance that is equal to one of these, C equivalent. So then C equivalent is going to be equal to C1 plus C2 when they're in parallel. In series they look like this. You have one capacitor, another, and this is C1, C2, the equivalent capacitance. C equivalent will be formula is 1 over C equivalent is equal to 1 over C1 plus 1 over C2. And if you have more than 2, then plus 1 over C3 plus 1 over C1. And you can calculate the energy in a capacitor. The energy stored in a capacitor is, because there's an electric field, there's energy stored in it. So energy stored. The difference, a battery has energy stored in it and a capacitor has energy stored in it. The difference between the two is the battery can discharge its energy slowly. A capacitor does it right away. So when you take a flash, when the flash lights up, the capacitor gives the energy right away, the flash. So the formula is half Q delta V. So energy is half Q delta V. And now if you know the connection between this thing, you can write it in either your forms of this, or you can get rid of Q and it will be half C delta V squared, or I can get rid of delta V and it will be half Q squared over C. So those are three formulas for the energy stored in a capacitor. And then we don't do capacitors with dielectrics. That's about it for this chapter. Okay. Now, next chapter.